Today's lesson, 11.2, is on box and whisker plots. We'll be looking at how you can use a box and whisker plot to describe a data set, and we'll be creating some box and whisker plots and using them to interpret the data set. So, vocabulary. Of course, we have a box and whisker plot, and a box and whisker plot shows the variability of a data set along a number line using the least value, the greatest value, and the quartiles of the data. The quartiles divide the data set into 4 equal parts. So those 5 numbers are the median, which divides it into 2 halves. You have the median of the lower half, which is quartile 1, and the median of the upper half, which is quartile 3. So the 5 data points that make up a box and whisker plot are the least value, quartile 1, median, quartile 3, and the greatest value. Example 1 is to create a box and whisker plot. So we're going to make a box and whisker plot that represents the ages of the members of a backpacking expedition in the mountains. The ages are listed below. I think the most helpful thing to do when you're making a box and whisker plot is to list the data from least to greatest. That's going to help us find our 5 numbers and find the median a little faster. So I'll write the numbers from least to greatest. And it's also helpful to know how many numbers there are. So there are 12 data points total, which means I'm going to separate my data into the bottom 6 and the top 6. So on the left, I have the lower half, and on the right, I have the upper half. That means the median, the number in the middle, median is 25. And we can also see that our lowest point is 18, and our highest point is 30. And the last thing we need to find is our Q1 and Q3 data points. Q1 is the median of the lower half, which is between 22 and 24. So Q1 is 23. And then Q3 is between 28 and 30. So Q3 is 29. Next, I'm going to set up a number line so that I can plot these 5 points on a number line and make my box and whisker plot. So we have our lowest point at 18, we have our highest point at 30, we have our median at 25, and our Q1 at 23, and our Q3 at 29. So I like to use a dot to make the lowest and highest points, and then the lines to make the quartiles and the median, so that from there you can just connect them with lines to make your box and whisker plot. Alright, example 2 is to interpret the box and whisker plot. This box and whisker plot represents the lengths of songs played by a rock band at a concert. Part A says find and interpret the range of data. We learned in 11.1 that the range is the highest number minus the lowest number. So to find our range, we're going to use our highest number minus our lowest number, and we get a range of 140 seconds. All right, describe the distribution of the data. It looks like the whisker on the left is quite a bit longer than the whisker on the right. So most of the data is on the upper half. We see that half of the data is between 220 seconds and 280 seconds. And the lowest data point is 160 seconds. The highest data point is 300 seconds. The median is 260 seconds. All right, part C says find and interpret the interquartile range of the data. The interquartile range is found by using Q3 minus Q1. So we have 280 minus 220, which is 60 seconds. That 60 seconds means that half of the data is between 220 seconds and 280 seconds. All right, part D says, are the data more spread out below quartile 1 or above quartile 3? As we said in part B, the whisker on the left looks longer, which means the data is more spread out below quartile 1, and the data is closer together above quartile 3. All right, so when one whisker is longer than the other, there's actually a word for that. That last example was skewed left, just like this first box. Skewed left means that the left whisker is longer than the right whisker, which means most of the data is on the right side of the plot. A box and whisker plot is symmetric when they're about the same in length, which means the median is the middle of the plot. And data is skewed right when the right whisker is longer, which means most of the data is on the left. All right, in example 3, comparing box and whisker plots. The double box and whisker plot represents the test scores from your class and your friend's class. So we have two different data sets, the one from your class and the one from your friend's class. Identify the shape of each distribution. Well, your class looks like it's skewed left, and your friend's class seems to be symmetric. I have those shapes color coordinated in part A. So part B says which test scores are more spread out. Well, your friend's scores have a farther range. So your class, the range is 100 minus, that looks like about 68. So 32, the range of your class is 32 versus the range of your friend's class is a lot bigger, 40. Which means the data of your friend's class is more spread out. It also looks like your class did better. The median of the scores of your class is 90, which means half of your fellow classmates scored an A, versus the median of your friend's class is at 80, which means half of their class got an A or a B. All right, and that concludes our notes for today. So, some summary questions. What are box and whisker plots? Box and whisker plots show the variability of data along a number line using the median, quartile, and lowest and highest data points. How do you create a box and whisker plot from a set of data? I like to start by numbering it from least to greatest. You find the median, and then you find the other 4 data points used to make a box and whisker plot. Data skews left if the left whisker is longer, meaning most of it's on the right. Data skews right if the right whisker is longer, meaning most of the data is on the left. Does that mean there are more data points in one of the quartiles? No. There's the same amount in the quartiles, it just means they're more spread out.